Jai Hind all of you. Today we are going to study about the inference theory in discrete mathematics. Myself Deepti Arora, Assistant Professor, MC Department, Ajay Kumar Garg Engineering College. So let's talk about what is inference theory. In Unit 3 of discrete mathematics in MCA syllabus, we have to study about some of the predicate logic and principles and then finding out the conclusion from these premises. So how to conclude the conclusion from these premises? There are some rules and we call those rules as rules of inference, and those rules are the part of inference theories. So we have to study those rules of inference, and which is known as inference theory, so that we can conclude the conclusion from the given premises. So let us know what is inference theory, what are the rules of inference. Let us study here. Inference theory. Inference theory is concerned with inferring the conclusion from the certain hypothesis or basic assumption called the premises. What are premises? Premises are the basic assumption or hypothesis, or we can say this is the antecedent also. So antecedent, we can say hypothesis or the assumption, that is we have already assumed or something that is given to us, that are known as premises, and we talk about it as P or any variable. We can give the premises any variable. For example, for most of the cases, we are giving the name to the premises as P, for example. And then by applying certain principles to these premises, we call the rules of inference. Certain principles that we apply to these premises, which are known as rules of inference, so that we can conclude the conclusion, or we can say consequent. And generally we call that consequent as Q. The premises are P and consequent or conclusion as Q, by applying these 6 rules of inference. What are these rules of inference? First one is law of detachment, or we can say modus ponens. Next one is law of contraposition, or we can say that is modus tollens. Third one is hypothetical syllogism, then disjunctive syllogism, conjunctive dilemma, and destructive dilemma. So what are these 6 rules of inference? Let us study. These are the 6 rules of inference. Again here, P stands for premises, or we can say hypothesis, or we can say antecedent, and Q stands for conclusion, or we can say consequent. So this is P and this is Q, and we are applying these rules of inferences. 6 rules of inferences are here that we have studied, and by applying these rules we can reach to our conclusion. So let us study what are these. Okay, first one is modus ponens, or we can say law of detachment. Okay, what is law of detachment? It says if we are having a premise and we are having P conditional Q. What is P conditional Q? P conditional Q is if P then Q. If P exists, we are having Q that with it. So if we are having a premise P, and from that premise P we are having a conditional Q, then what we can get? That is Q as conclusion. That is modus ponens. That is the rule of modus ponens. That is, if we are having P and we are having conditional statement and we are making an and here, what we get? The Q as the conclusion. Second one is modus tollens. Modus tollens states that if we are having a conclusion with us and we are negating that conclusion, Q, or we can say we are having another premise Q here and they are negating that premise, and again we are having a conditional statement P conditional Q. What will the response? We are having the conclusion as negation of P. We have to remember that if we are having negation of Q, any premise, and we are having conditional P to Q, what will be the result? That is, we are having Q. Or we can say, if from both the statements, we can, if we are making AND with them, the conclusion will be equal to negation of P. Now, what is hypothetical syllogism? Hypothetical syllogisms say that if we are having P to Q and Q to R, that is P conditional Q and Q conditional R, what will be the result? Q will be cancelled out, and what is the result? P to R, P conditional R. It is simply equal to, that is, we are having the we can say P to Q and Q to R. We can say this is a transitive rule of set theory. That is, what is that? If we are having AB and then we are having BC, then definitely we are having AC. It is similar to that. Now again, disjunctive syllogism. Disjunctive means or. That is, we are having P or Q and negation of P. If we are having AND of with the negation of P and the P or Q, what we will get? Q. Now addition, simple addition, we say P, then P or Q. Addition sign is or. Then simplification, we are having AND. Conjunction, P and Q, and disjunction or resolution. What resolution say? If we are having P and Q, P or Q and negate of P or Q, then P will be cancelled out. We are having Q or R. That is, we are having AND of P, then P will be cancelled out. We are having remaining, that is Q or R. So these are the 6 rules of inference that we have to remember, and through these 6 rules of inference theory, we have to reach to the conclusion. How we reach to the conclusion, how we apply these rules. So let us try some of the questions related to it so that we can use these rules and apply the conclusion. Okay. First one is law of detachment. We are having an example of law of detachment. What was the law of detachment? We are having P and then P conditional Q. Then therefore, we will reach to the conclusion Q. So we are having a first premise here. This is also a premise here. And this is also a premise here. So we are having one premise stating P stands for Mohan can work hard. And second, Q premises he will get a job. Then premises P and Q and P we are having, and we have to draw the conclusion Q. That is for rules of inference. So what we are having? We are combining. First is P conditional Q. If Mohan can work hard, then he will get a job. This is P conditional Q. If Mohan can work hard, in P we are having Mohan can work hard, and in Q we are having he will get a job. So what we are doing? If Mohan can work hard, he will get the job. We were writing in the conditional statement. Next, and then again P. What is P? Mohan work hard. Mohan is working hard. So what the conclusion? Therefore, he will get a job. That is the Q. Simple. Okay. Let's try the next one. Test the validity of the following argument. What is the argument? If Ram work hard, he will get a job. That is, we are having P conditional Q. Next, Ram works hard. We are having P. Then therefore, he will get a job. Therefore, he will get a job means Q. Yes, this is a valid statement. What is this statement again? This is modus ponens. Yes, this is a valid statement. We are having P2Q, P and Q. Okay. Next one. If a man is a bachelor, he is unhappy. So next one is, if man is unhappy, he dies young. So let's find out first. These are the conditional statements. So what the conditional statement is doing and how we can conclude to the. So we have to check the validity of the argument. So let us assume P as man is a bachelor and Q as man is unhappy, and third one is R is man dies young. Now what the syllogism first says, it says if man is a bachelor, that is P, he is unhappy, conditionally Q. Now S2 states what? Statement 2. If a man is unhappy, he dies young. That is man is unhappy is Q. Then he dies young, R. And what the statement 3 is saying? Bachelors die young. That is P2 R. So what we are concluding, is this a valid statement? Let's check. What we are having in resolution, if we are having P and Q and not of P or R. But here what we are having, okay, we are having P2Q and Q2R, then we are having P2R. That is hypothetical syllogism. Yes, it exists. So we are having P2Q, Q2R and again P2R. This is valid argument, which is rule of inference number 3, that is hypothetical syllogism. So we have up till check 2. First one is, that is law of detachment, or we can say this is modus ponens. And second one is, again we are having the same arguments and we are considering that whether it belongs to any of the rules of inference. We have given the statements with the conclusion and we have to check the validity of the argument. And again we find out that yes, it belongs to the first rule of inference, that is modus ponens. And now the third one is, this is the rule of inference third, that is hypothetical syllogism. Now next. Okay. Show that the premises lead to the conclusion. So what are the premises? Let us check. It is not sunny this afternoon and it is colder than yesterday. Next, we will go swimming only if it is sunny. Next, if we do not go swimming, then we will take a canoe trip. Then if we take a canoe trip, then we will be home by sunset. And last, lead to the conclusion, we will be home by sunset. We have to show all these English statements into premises. You can see from here that all the statements are related to each other. Afternoon, then colder than yesterday, swimming. If it is sunny, it is related to the previous one. Then swimming, it is related to previous one. Canoe trip, related to previous one. So we will break the statements. How? Okay. Premise P. It is sunny this afternoon. We have taken this. Next Q. It is colder than yesterday. Then third, we will go to swimming. Again, if it is sunny, it is already given. We have taken in previous that it is sunny. Next, we go to swim, already taken. We will take a canoe trip. We have put in S. Then T, we will be home by sunset, which is also our conclusion. How we can write these statements? Using these premises. See. Negation of P. It is not sunny this afternoon. We have take the premise. It is sunny this afternoon. So we have negated. Not of P. Then and. Put the sign of and. It is colder than yesterday. Simply we have taken it is colder than yesterday. We have put the Q premise here. Next, we will go to swimming. We will go swimming. R. Then if it is sunny, only if it is sunny, then we will have taken conditional statement, because conditional statement say P only if Q. So this is a conditional statement also. So we have taken P here. Now if we do not go swimming, that is negation of R, and we'll reach to the conclusion S, that is we will take a canoe trip. Now if we take a canoe trip, we will go to home by sunset, then S to T. And last, what is the conclusion? We will be home by sunset. So last one is T. Next, show the premises implies the conclusion. What is the premise? Everyone in the discrete mathematics class has taken a course in computer science. And next, Marla is a student in this class. Imply the conclusion, Marla has taken a course in computer science. How we can write it as? See, everyone. So we have written for all. Next, DX. D stands for discrete mathematics. And for everyone. Everyone के लिए, for everyone means X. X is a student in a class. So we have taken X as a student in a class, and X is a student enrolled in discrete mathematics. So we have taken discrete mathematics D. So D and every student of class enrolled in discrete mathematics has taken a course in computer science. So for computer science, I am taking C here. So computer science, every student, that is X, belongs to computer science. Now, Marla is a student in this class. So the student in the class is Marla. So Marla, discrete mathematics, Marla, which is a student in class of computer science, Marla. Now, imply the conclusion, Marla has taken a course in computer science. Yes. Next, D Marla. Marla has taken a course in computer science. C Marla. Okay. Next, show the premise. A student in this class has not read the book. Everyone in the class has passed in the exam. And last, imply the conclusion. Someone who passed the exam has not read the book. So how we will write these steps? Okay. A student in the class. Let us find out. Let X be a student in the class. Okay. X is a student in the class. So B stands for book. So BXB, X has read the book, and PXB, X has passed the first exam. So the premise will be, there exists X such that a student, a single student, so there exists a school student in the class CX has not read the book and has not, so not indication, not sign, read the book. Again, everyone in the class, so for all, X, everyone ho gaya. Then class CX passed in the first exam, passed the exam. Now, last, imply the conclusion. Someone who passed, someone means there exists only one person. So, someone, there exists X, who passed the exam, PX, has not read the book and not read the book. Got the point? So, we have broken these steps here also. These similar steps are broken here. So, next one, these are for practice. Let us practice these. All the students in the class understand logic. So, for all X, okay. So, all the students in the class understand logics. So, for all X in the class, students in the class. So, CX understands logic. For understanding logic, I am taking U. Okay, for all. Next one, Xavier is a student in the class. So, C, Xavier. And from this, I have concluded that C. Xavier understand logic. Okay. Therefore, Xavier understands logic. Therefore, Xavier understands logic. Get the point? It is similar to Marla example. This one. We have done same here. This is the same example. Now, every computer science major takes discrete mathematics. So, for computer science, I am taking C, and for discrete mathematics, I am taking D. So, what is the here? For all x, Cx and Dx. Okay. Natasha is taking discrete mathematics. So, D, Natasha. And here we have concluded C, Natasha leads to D. And what's the conclusion we got? Therefore, Natasha is a computer science major. Hope you are getting these points, how I am solving it. Next one. All parrot like fruit. So, for all x, for parrot, I am taking Px. And for likes fruit, I am taking F. All parrot like fruits. Next one. My pet bird is not parrot. So, for pet bird, I am taking A. My pet bird is not parrot. So, not of P and A. My pet bird is not parrot. Therefore, my pet bird does not like fruit. So, pet bird. Again, for pet bird, I have taken A, and not like fruit, not like fruit. Okay. Everyone who eats granola every day is healthy. So, for granola, I am taking G, and healthy, I am taking H. So, for all X who is eating granola is healthy. Now, next, Lara is not healthy. Not of H. So, what from here we get? G, Lara, H, Lara. Because we are talking about only one girl, Lara. Lara does not eat granola every day. Therefore, not. Okay. That is not of P, none G to H. That is Q to P, not of P, and we are getting the conclusion not of Q. That is your tollen. This is modus ponens. And again, this is modus ponens. So, these arguments are valid again, but this is not a valid argument because there's no such argument exists, and again, this is also a valid argument. You can see here, not of Q, not of P again, not of Q and G to Q. Okay. So, this is all about the inference theory of rules of inference, and this is all about it. Thank you.